So for tonight's presenters, as usual, me, Joe Deli Carpini, I'm the Science and Operations Officer at the office, and I cover the science program, which is research and training. With me tonight, three of our star meteorologists. We have Bill Latham, who happens to be our climate team program leader and is well-versed in all things climate. We have Bryce Williams, who manages our social media program and usually helps me out. And we have Rodney Chai, another meteorologist of ours who has a pretty good climate background. Rodney, before he came to us, worked at the civilian side of the Navy out in Livermore in California and is well-versed in things like global circulation. So they're all going to take turns presenting different climate topics for you tonight. So with that, I will hand it off to Bryce to get us started.
All right, thanks, Joe. Welcome, everybody. Looking forward to teaching you guys a little bit about climate tonight. We get a lot of questions about climate and a lot of people very interested in weather of the past and what kind of trends we can expect. So hopefully you learn a little something tonight. So just want to start off with an old saying you may have heard before. What the way we like to think about climate versus weather is sometimes people will say climate is what you expect, the weather is what you get. So basically, we're looking at the period of time is the main difference. So weather is going to be the current state of the atmosphere with respect to all sorts of things. You can see listed there: temperature, humidity, precipitation, visibility, all the things that we as meteorologists forecast from on a day-to-day basis. That is the weather. And us here at the National Weather Service make a forecast out to 7 days. So that is the limit to where, how far in the future that we will predict. Now, if we're talking more of the long-term weather, as it were, that would then be referred to as climate. So it is basically the prevalent characteristics of the weather in a certain place on the globe. So we'll get into a little bit more on what that exactly means, but first here, just some examples of weather. This is all weather. Now, you see pictures here, you recognize, of course, lightning, you have an ocean storm, maybe a nor'easter, rainstorm, a tornado. All these are types of weather. This weather, though, can go into what makes up the climate. So let's move on to the next slide. So there you go. Just reiterate the condition of the Earth's atmosphere in a brief period of time, say a day or a week. Now, the climate is, as I said, a long-term thing, so the average over an area for many years. And just throw in a quick example of a climate for, say, Worcester, Massachusetts. The normal high temperature and the normal low temperature, which would be 71 and 53 on June 5th, picking a random day. And the fact that we can tell, based on that date and that location, what the average of the normal high and low is, that is climate. And you can see the map here has all sorts of just different, the United States is broken up into many different climate zones. And so that map on the previous slide, there shows how intricate, especially if you look into out west where we start to get a lot more elevation influence. It gets pretty messy with lots of different climates and microclimates. And you can kind of look at the Appalachian Mountains. You can see that higher elevations have very different climates than the lower elevations do. So the United States is full of all sorts of different kind of climates. All right, so to get a climate record, it all starts with the weather records. And so that is why we at the Weather Service and our system and network of partners and people that we work with are always taking weather observations, hourly, every day, every day of the year. These are constant observations that are usually getting taken at various airports across the region. And so a lot of times it's just very convenient to have these observation stations at an airport because you often have an unobstructed area that's flat, that's away from, like I said, obstructions, and a place that's often, staffed and people can get to those observation stations to perform maintenance and such like that. And also, there's just lots of airports around that's very convenient location. So we have not only the airports, we also have a network of cooperative observers. You may have heard of our co-op program, public just regular citizens that can sign up to keep a very detailed record of the weather in their backyard or wherever their station is across southern New England. And then we also have the CoCoRaHS network, and that is, as far as climate's concerned, is only recording the rainfall. And so we have many volunteers across southern New England that are always reporting the rainfall that they get, and then we keep a log on it online and other records, backing that up. And so in order to become a climate site, we need a minimum of 10 years of complete and continuous observations. And so if we can get a site to that milestone, that is when it becomes eligible to be kept, the record of that kept at NCEI, which we'll get into what that is later, but it's basically the organization that is tasked with keeping track of all these record sites and their data. So back to a little more detail about the airports I was talking about. So like I said, many locations use ASOS systems, which I will explain what that is on another slide in the future. But often, the location of our climate sites, say Boston, has moved around several times over the years. And I'm going to show you a brief history of our climate sites here soon. But just so you know, a lot of these sites have been moved and shuffled around to find the best spot. But many of them have been where they are now for over 100 years. And so we're getting into a really good long period of no movement. Now, these locations record both daily, monthly, and seasonal climate summaries, which we're always sending out. I know Bill just sent out the monthly climate summary for September, now that we're finally into October. And so you can look that up on our website, and we'll explain a little bit how you can do that later. We also went over that on our last webinar if you were able to join us. So these observations come from what's known as an ASOS system, or an Automated Surface Observation Station. And so you can see one pictured there on the left. Obviously, that's not in southern New England, given those snowy mountains, but these instruments are the same everywhere you go. If you see the map on the right, that is showing the observations at all these different airports across southern New England. So you can see every one of these sites is some sort of airfield or airport, and it's got an ASOS station or a similar type of station that is always sending in wind direction, wind speed, temperature, dew point, all that kind of stuff. Cloud cover, it tells us the number of, or the percentage of cloud cover in the sky and how high the cloud ceilings are. They're all very important stuff for airports as well, which is another reason it's good. Airports are a good place to have them, because they're useful for the airports themselves, not just for keeping the climate records. Now, just a quick definition time for the difference between normal versus average when it comes to climate. So when we say average, that is going to be for what's known as the period of record. So it's basically, that just means whatever the length of the recorded data at that station is. So say some stations have been recording data for over 100 years, that would be the period of record. And so if you take all that data together, you would call that the average. Now, if you're talking normal, that is based on a standard number of years, and most are using a 30-year model. So basically, the climate data that we have now, when we're talking about what's the normal high for today or the normal low for today, that's based on the years 1981 to 2010. So now that we're about to get into a new decade, or we have just been started a new decade, however you want to define that. Either way, we're going to be updating those climate normals for moving that 30-year window up 10 years here in the next year or two. I'm not sure exactly how quickly that happens, but yeah, we will be updating those soon. So that's how we calculate our normal 30 years. So just a little dive into the official climate sites of southern New England. We have 6. So our first one is Boston, and the records at Boston date back to 1872. It started in downtown Boston, but then it has since moved to Logan Airport back in 1936. Then you have Hartford, Connecticut, where records go back all the way to 1905. It's not quite as old as Boston, but it did move, also moved. It started in the downtown, just like Boston, and moved to Bradley Airport in Windsor Locks in 1949. Then we have Providence, and those records go back to 1904, started downtown, and again moved to T.F. Green Airport in the 30s. Then Worcester records date back all the way to 1892, so a little older than Hartford and Providence. And again, the theme continues, started in the city, moved to Worcester Airport in the 40s. So all these sites started at the city and moved in the 30s or 40s to the airports. Now we also have many of you, if you're weather nuts like we are, you may have seen this or even taken a tour of it. This is the Blue Hill Observatory up in the Blue Hills near Boston, and it has been keeping a continuous record from all the way back to 1885, January 31st, 1885. The longest continuous operational weather observing station in North America that's stayed at the same location. So it's pretty remarkable and very cool if you ever get a chance to go take a tour. These are some pictures I took on a tour I did, and they can take you to various parts of the observatory and show you all the data they're collecting all the time. It's very cool, but it also just cool how old it is. And it was also the first site of an upper air kite observation. So kind of like we send weather balloons up to take observations now, at one point in history, they were sending kites up and they could bring it back down. Very interesting. Now, there are two more climate sites in southern New England that are not in our area because we don't include Berkshire County, Massachusetts. That's handled by Weather Service Albany, New York office, and then the New York City office to our south handles the southern Connecticut. But Bridgeport, Connecticut is a climate site. Is at the airport, and it goes back to 1948. So it's quite a bit newer. And then Pittsfield, Massachusetts is also a bit newer, back to 1925, and it too is at the airport. Okay, so all this data is getting ingested into computers and wherever it's going. So where does it go once it's recorded? Well, the answer is many places, but one would be the state climatologist. So we have people that work for the state, and their entire job is the climate, and they are the representative for the climate records. That's who, all these government agencies and businesses and things, that anybody that needs all this climate data, they go to the state climatologist, and they can help facilitate not only the collection, but especially the sharing and the use of that climate data for however many plethora of uses that it has. Now, there are also regional climate centers. So you may be familiar with the Northeast Regional Climate Center. We often use a lot of their data. They put out a lot of great imagery, plotting the climate data for different months and seasons and years, ranking how dry or how hot or how cool the region was. So we are pointing people to the Northeast Regional Climate Center a lot, and they're basically representative for the climate records for all the states in the area. And again, just like the state climatologist, facilitating the collection, sharing, and the use of that climate data. So there's the link there if you're interested for the Northeast Regional Climate Center, and is located at Cornell University in Ithaca, New York. Now this is what I mentioned briefly earlier. This is called NCEI. So this is the National Center for Environmental Information. So this is the ultimate destination of all this climate data is NCEI. And so basically there are 4 locations in North Carolina, Colorado, Maryland, and Mississippi. And this is the national representative of climate records within the whole United States. So this is the go-to person, the go-to organization. If you're looking for climate data, you may get passed up through a chain of command, but you're pretty much always going to end at NCEI. So there's a link as well if you want to poke around on there. There's all sorts of information you can order. You can look at online yourself, and you can order it. They'll send to you. You can get a lot of good data on there. Very interesting. All right, and with that, I will pass it on to Rodney.
Well, thank you so much, Bryce. That was a great introduction. So now let's take a look at this past summer. How did this past summer fare for the continental U.S. and as well as for us in southern New England. But first, let's take a look at the global view. And if you think this summer was hot, it was hot for a lot of people around the world. In fact, it was the warmest summer on record in the Northern Hemisphere. Of course, the Southern Hemisphere had their winter while we were having our summer. And this was, and remember what Bryce talked about, the climatological normal. In this case, we compare what we experienced to the 30-year normal. And for now, it is 1981 to 2010. But then by 2021, this 30-year normal will be shifted to 1991 to 2020. And this is the temperature anomaly compared to the climatological normal. So you can see that much of the Northern Hemisphere has above normal temperatures this past summer. And besides the air temperature, as meteorologists, you may be surprised to know that we are very concerned with sea surface temperature. And because the ocean temperature has a huge impact on weather patterns, and especially in southern New England, where we have, eastern Massachusetts and Rhode Island, we are right by the ocean. A lot of our storms, when we forecast storms, we have to take into account the sea surface temperature. And, this summer we experienced the second warmest global sea surface temperature in 141 years of bookkeeping. On this map, you can see the reds represent areas where the ocean waters are much higher than climatological normal. Again, that's 1981 to 2010. But when we talk about the rankings, the second warmest on record, that's the second warmest in 141 years of record. So, they are related, but the rankings, it's important to know that that's based on the bookkeeping that we have. And in terms of how dry it has been, much of our areas under some kind of drought conditions, not surprisingly, given how dry it has been. And it has been a drier than normal summer for not just for us in the Northeast, but also for the West. And unfortunately, the dry conditions have led to just so many wildfires. It's very unfortunate. And I used to live in California, and I can tell you, once the rain shuts off in May, the storms don't get going again until November. And so, unfortunately, the people in Western U.S. still have to deal with wildfires probably until November. So this is a snapshot of the main weather events this past summer, and this was taken from the State of the Climate report. And for us in the Northeast, the main event was really tropical storm, formerly Hurricane Isaias. Remember, it made landfall in the Carolinas and kind of went up the Mid-Atlantic coast and up Hudson Valley. For us in eastern Massachusetts, we didn't really get much rain except for the damaging straight line winds at the end. But people out west towards the Mid-Atlantic states, they got a lot more rain. Some places got up to a foot of rain. We could use that rain. Further towards the Midwest, there was the derecho, and derecho is basically, if you think about, it's basically a line of straight line winds. You can exceed 100 miles per hour. Sometimes derecho, under the right conditions, can cause more damage than a tornado outbreak. And then further west, again, we had the drought conditions, anomalous warmth, and also unfortunately the wildfires. And further up north in Alaska, the ocean experienced some of the lowest amount of sea ice concentration on record, and that's not surprising given how warm this past summer was. So that's just a snapshot of the significant weather events this summer. All right, so this map that you are looking at is, this is the statewide average temperature ranks, and we take the temperatures, we average them across by state, and I just want to bring your attention to southern New England. So you can see Massachusetts, Rhode Island, and Connecticut ranked 126, and that's the record warmest summer in history. And when we talk about June to August, that's meteorological summer. And so, and again, recall what Bryce, talked about the difference between record versus normal. This is record. So we have 126 years of record, and this summer was the warmest on record. And in terms of precipitation, you can see some very low numbers for southern New England, Massachusetts 17, Rhode Island 9, and Connecticut 11. So basically, that's simply put, this past summer was among the 20 driest summer on record, and not surprising because of how little rain we received. And also, if you see much of the West, they also had some of the dry summers on record. So remember, Bryce talked about the 4 climate sites that we have. So we have Boston, Providence, Worcester, and Hartford, Connecticut. And I just want to walk you through. So this map of figure you are looking at, it actually incorporates both climatological normal, that's 1981 to 2010, and also the record. So you see the red line and blue line, that's climatological extremes based on the years of record that we have. All our climate sites have over 100 years of record, and basically that's that line is the red line. That's the daily maximum temperature on record. So and then looking in the middle of the graph, we see that's the brown shaded region. That's the normal temperature range, and that's based on the 30-year normal. So by next year, since we are moving to 1991 to 2020, that brown region may shift around, shift up, shift down. We will see what happens. And the blue bars, that's the temperature range, observed temperature range this summer. So if the blue bar falls within the brown region, that means we have pretty normal temperatures. But if it is, closer to the top, that's that's above normal, and maybe it's like close to close to the record high temperature. But if it is the other extreme, then you're talking about anomalous cold. So it's clear that from this graph, the above normal temperature days far exceed the below normal temperature days. So that's why we had the warmest summer on record. And that's Hartford, Connecticut, a very similar story to Boston. And we will just step through this since I've explained to you how to interpret these graphs. And this is kind of a subtle, somewhere after, I would say, mid to late August, we kind of trended towards more normal temperatures. If you remember, some of the high heat actually happened in late July to early August. And you can see Worcester, one of the days actually, kind of late July, they actually set a daily record maximum temperature. Let's talk about the Climate Prediction Center, the CPC. They're located in College Park, Maryland. And this was, they update this pretty frequently, but this was from a week ago. And on the left, you see the 6 to 10 day outlook. So that's the temperature compared to normal. And you can see much of the eastern half of the U.S. The CPC predicted below normal temperatures, and the brunt of the cold is located over the Midwest, even down to the deep South. And for us, we're kind of on the fringe, So when you're kind of on the fringe, you can go both ways. So the CPC has kind of is saying that there's an equal chance of seeing above normal temperatures and below normal temperatures. And on the right-hand side, that's the precipitation outlook. And you can see much of our area is under, there's a higher than normal probability of wet conditions. And, sure enough, most of us, we received some kind of rain yesterday from the high wind event, but further west, they received, over 2 inches of rain. Whether this high wind event would change the pattern to a more wetter one, we will have to see. But at least we got some beneficial rain. So the CPC also, this is an experimental product, and this product is the risk of hazardous temperatures. And now this is so important. There's so much information on the web, and people want to get the most important information quickly. So this map kind of summarizes the hazards in one graphic, an easy to use format. And unsurprisingly, much of the Midwest has a high risk of below normal temperatures, and the West has a high risk of warmer than average temperatures. That's what this graphic is telling you. And the CPC also collaborate with partners from around the country and the world to derive this global tropical outlook. For us here in southern New England, we are concerned about the threat of tropical storms and hurricanes. And we're still in the thick of hurricane season, but a lot of times, and we will go through this in more detail shortly, what happens in the tropics has such big implications on the weather for us, in southern New England, and that's why we keep a close eye on what is going on in the tropics. And the CPC collaborate with the Navy, and there's also University of Albany and some other partners around the world to just keep an eye on what is going on. So this is the drought monitor, and as I mentioned earlier, we are most of us here are in some kind of drought. And here, the darker the shading, the more extreme the drought is. And not just for Northeast U.S., but for much of the Four Corner regions, they are kind of in an extreme to exceptional drought. And obviously that didn't help for the wildfires. And this is just zooming into our region. Again, you can see the orange shading, that's moderate drought. The red shading, that's extreme drought. And that's one category less than the most extreme drought. And this is just looking at the drought outlook. This is just looking, the next few weeks based on the, what the CPC thinks. Is it going to rain more? Is it going to be a wetter pattern? For us, you see that that green shading represents drought removal is likely. So we will cross our fingers and hope that would indeed be the case. All right, so I'm going to talk a little bit about teleconnections, and basically, at my former job, I used to work for the Climate Support Division for the Navy out in California, and we are so concerned about teleconnections. And some of you who are very passionate about weather, especially in winter weather, you would think of people would throw terms like NAO, AO, La Nina, El Nino around. Those are different kinds of teleconnections. And basically, the nutshell about teleconnection is that, the sea surface temperature thousands of miles away in the tropics has a certain correlation with the temperature and precipitation we get in winter. So you may have heard about, if you like snow, you want negative NAO. If you want a warmer than usual winter, you kind of want an El Nino. So El Nino is the colder phase of what we call the ANSO, El Nino Southern Oscillation. And basically that's, in a nutshell, without getting into too much detail, the thunderstorms that occur in Southeast Asia have a certain impact on the sea surface temperature in eastern and central part of tropical Pacific, which then have impact our weather here in New England. So the CPC a few weeks ago, they issued a La Nina advisory for continental U.S. And what this means is that they have a 75% confidence in La Nina conditions developing in the coming days and persisting through winter of 2020 and 21. And La Nina basically is the opposite of El Nino. Last year we actually had a weak El Nino, and La Nina is the colder phase of ANSO, and you can see on the left diagram there's all the blue shading in the tropics. That's basically lower than normal sea surface temperature in eastern and central tropical Pacific. And when we see this kind of pattern, it increases our confidence of what we call a more amplified jet stream because of a blocking high pressure over the Pacific Ocean. And when you have a more amplified jet stream, you get a deeper trough, and that favors the invasion of colder Canadian air, especially in winter. And remember, if you like snow, you need two key ingredients. You need cold and you need moisture. So you have the cold, and for much of the upper Midwest, they have a pretty good shot at a colder than normal winter. Not 100% because there are other factors, but when you have La Nina, you favor a colder and wetter winter for the northern half of the U.S. And for the southern half of the U.S., you have a drier and warmer average winter. So I'm just going to pass it on to Bill to talk about the next slide.
All right, thanks, Rodney. So this next slide here, so we're looking at the climate classification schemes across southern New England. Now, Köppen climate type is a climate classification system that was developed originally in the mid 1800s to mid 1900s from a climatologist named Köppen. It's since been updated, but it falls. There's 5 general climate groups that the system has. They're called tropical, dry climate, temperate climate, continental climates, and then lastly polar and alpine climates. Now, for southern New England, much of the interior falls into the group of continental climates, which is those shades of blue, which there's the warm, humid summer continental and also the hot summer, humid continental. And then if you look at our coastal locations and also across much of southeast Massachusetts, we fall more into a different group, which is called the temperate climates. Now, there's a lot of different temperature things that happen to put these into these groups. But one of the biggest things for all of these groups is that we typically see the same precipitation for the most part throughout the year. There's no big drastic differences between the seasons on how much precipitation that we receive. So this is just taking a look at the Providence, Rhode Island climate information. I think this is from, I believe this is like a Wikipedia pullout, but you can see this has the 1981 to 2010 normals. And you can kind of see what I was talking about with at least the precipitation, that there are some differences from month to month, but overall the precipitation amount that we receive throughout the year is pretty uniform. And you can see our warmest month in Rhode Island, where we get our warmest temperatures, are usually average in July, and then some of the coldest readings we get are in January. So this slide here is showing basically when you're looking at all of these, they're called wind roses, and these are for three locations across southern New England. We've got Hartford and Bradley on the left, Boston and at Logan International Airport in the middle, and then the Nantucket Airport on the right. And the way that these work is the length of the lines are showing you the frequency or how often a wind is coming from a particular direction. And then the coloring that's on this is showing the typical wind speeds within these frequencies. And you can kind of see there's a big difference depending on where you're located in southern New England, where Hartford and Bradley sees predominantly winds out of the north and the south. And also those wind speeds are typically, they're on the order of 10 to 15 knots, a little bit lighter than the winds at both Logan and Nantucket. But you can't even see there's a difference in the predominant wind direction from Boston and Logan to Nantucket, even though they're both close to the ocean. Boston has more of a westerly wind direction, whereas Nantucket favors more winds out of the southwest. And then this is just this is a site if folks are interested to see with the climate changing and the water levels on the rise. This kind of gives you a good place to look at, like to visualize in some historic spots what it would look like with the water levels rising, and it gives you options to change it to different levels. But we don't have it pulled up on here, but if you go to that link that you see on the page here, you could take a look at that. So how to find climate data? So there's several different locations. The one that Bryce and Rodney were talking about, the National Centers for Environmental Information. If you go to, it's ncei.gov. And that will give you an option to find climate data. And another place to go is climate.gov. There's lots of different, it all just depends on what you're particularly looking for. But these would be the couple places you could go to find that information. And then when it comes to the climate information that we put out, if you go to weather.gov/Boston, and you hover over the climate and past weather and then click on past observed weather, it will bring you to, it'll bring you to this page. And if you go to on the tabs on the top and click on the now data, you can look at different records and figure out whatever in particular you're looking for. You can do that through these different queries. And if there are any questions on it too, you can always shoot us an email and we can try to point you in the right direction, because unfortunately there's just so many places to find information, and if you're not used to how to look for it, it's a very particular on how you have to find stuff sometimes. And then another page to take a look at, if you're interested in the top 10 daily weather records on the weather.gov Boston page, if you go to the very bottom of the page under the climate group, there's a thing called Top 10 Daily Records, and then this is just going to be for those 4 climate sites for Boston, for Worcester, Providence, and for Hartford. But if you wanted to look at a different office, there is a way to do that. But if you went to that link on the bottom, it'll bring you to a page that looks like this. And what you can do is it defaults to set to what the current date, and you can change the date select by under that right, and that will bring up a calendar, and you can move it to any particular day that you're interested in, and then you choose whichever site you're interested in data for, and then when you click on that button, it will bring up an option of either looking at the highest temperature for the day, the coldest high temperatures for the day, the coldest temperatures for the day, and also in precipitation and snowfall. And so that's one way if you wanted to look at the daily climate information. That's a quick way to look up like the top 10 for the day. And then another place to find climate data, and then this is more with regards to when we've had significant weather events. If you again go to weather.gov/Boston and hover over the climate and past weather, if you go to the very bottom where the arrow's pointing there, it says past weather events, and it will bring up a page that looks like this. And anytime we have a significant weather event where we send out summaries that have where we've had snowfall, heavy rain, if we've had an ice storm, strong winds, or if it was just a windy day, if you come here, you'll get a calendar, or what will first come up is the most recent storm that's occurred, and it will show whatever happened. So I think if you looked at there now, you'd see the highest winds because of the windstorm we just had. But you can go back and see what the snowfall amounts that were observed. And these are all reports that we've gathered from folks like yourself giving the office information, or even from some of the automated systems that we have. But this is a way for you to kind of take a look at past weather events that have been impactful across southern New England.
All right, and with that, thank you, Bill, thank you, Rodney, and thank you, Bryce. We have some resources here listed that we included in the presentation, so we'll leave this up as we go through some questions, and I will take a look at those, and everybody can help me. Oh, let's go back. There we go. And they can, my helpers here can help out. So let's see. We will start. Let me find the questions. Let's see. From Anthony, can you recommend a relatively simple yet accurate rain gauge? Anyone want that?
As someone who lives in an apartment, I can't speak to that. I don't have room for it.
I think the best resource for them would be doesn't Coco Roz
Yes, Anthony, if you go to cocoros.org, there's a couple of places you can purchase. It's a plastic rain gauge. It's called a 4-inch rain gauge, but that's kind of the standard one used by CocoRoz observers. It costs about $30, and it usually ships pretty quickly. That works pretty well. If you're looking for something a little, less than that, you can pretty much go to any garden center or hardware store and probably find a smaller rain gauge for less money that would still work. Usually it's just the one tube that will measure up to an inch. But if that's what you're looking for, that will work. If you want something that will, measure more than an inch of rain, I would say go to cocoros.org, and you can order a rain gauge from there. Let's see, question from John. Are climate averages skewed to the right because of a right tail in the data? I'm going to give that one to Bill. He's our climate guy.
So yeah, that they would be, and that is also part of the reason why when we're looking, when we are trying to categorize what's going on with the current climate, that's why we have the normals, is because it's a better representation of the current state of the climate. And so but yeah, if you looked at just the climate averages, then the data would be more skewed to the right.
Okay. Let's see, another climate question from Sarah. This is a good one. When the new normals from 1991 to 2020 are put into place, which will include a decade of record temperature highs and rainfall totals, how will that affect our ability to understand how much our climate has changed? For example, could or would 120 degrees in Phoenix be considered normal? Well, I'll start and then I'm going to hand it to Bill. But yeah, think for us. I'm going to use Boston as the example. So the mid 1990s and especially through the 2000s, we had many years of above average snowfall. So now our normal snowfall for Boston is likely going to go higher. And I'm sure similar to other areas, temperature normals will likely go higher as well. So that's why I think it's more important to look at the period of record as opposed to just the normals for a 30-year snapshot for a station's record to understand how much the climate is changing. And that's all I'm going to dig into, but I'll let Bill talk a little bit more.
Yeah, well, I mean, I think the other thing that folks can do, although it's unfortunately not very easy to find the information, but you can find past climate normals, and then you could compare the normals between different periods to see how things have changed. That's kind of another way to go at it, but yeah, I mean, it will affect our ability to understand how much the climate changes. But again, when they do the 30-year normals, it's kind of more to get what's happening currently, the current state of the climate. If you want to look at like longer term trends, you kind of have to look at like Joe was saying, the period of record.
Okay, and Bill, I'm going to throw another question at you from John. How long is the seasonal lag in southern New England?
You got me stumped on this one. How's this? Do any of the other organizers have any feedback?
Yeah, that's a good question. I'm hearing silence.
Yeah, I think I'm going to take a stab at this. This is Rodney. If I understand this question correctly, we are talking about what is the time lag between, so say it's summer, the maximum sunshine or insolation and the maximum temperature, and then in winter, the reverse. I mean, I would say, in summer, in New England, and I've only been living here for just over a year. It seems that, well, the maximum sunshine happens during summer solstice, that's June 21st, 22nd, but we don't get our hottest temperature, at least this past summer, until late July, early August. So you take June 21 and, late July, that's about 5 weeks. And then in winter, we get the least amount of sunshine on winter solstice, just December 21st or 22nd. But we don't really get our coldest temperature until late January, early February. And so again, that's another time lag of 5, maybe 6 weeks.
I think that's what he was referring to. Good catch, Rodney. I think you're right. Okay, good question. And let's see, a question from Joan. How often do you have training for cooperative observers? Typically, well, we don't have too many of them, Joan. Some of them are located, we have people at homes. We have things like, water departments and places like that are the cooperative observer stations. Typically, we don't add a lot of them because there is maintenance involved in maintaining their equipment, things like that. So we often don't, seek new cooperative observers. We have them. We have the airport stations like Bryce was talking about. What we do like to add are the CoCoRaHS observers actually for rainfall and snowfall. So if anyone out there has an interest in being like a volunteer observer for us, I would recommend go to cocorahs.org and you can sign up to become a rainfall observer. You just need to get a rain gauge. And you start reporting. So, rainfall is reported, snowfall, snow depth. If you really want to get into it, you can melt the snow on the ground and find out how much water's in it. That's useful for flood potential as we go into spring. So I would say if you want to get involved, go through CocoRa's. We have between the 3 states, we have about 430 observers, but we can always use more. They like to have literally, at least one observer in every community, which is a big goal. But the more observers we have, the better. So we have, for example, for rainfall, we have the airport stations. We have our daily cooperative observers. And then we can really fill the gaps with CocoRa's observers. So the maps that we put out after a big storm like we had the past couple of days, a lot of those reports are from CocoRa's, and it gives us a lot more detail and helps us out also with the ongoing drought conditions. We know how little rain has fallen. So that's a great thing to become involved in. I'll put in the commercial for CocoRa's here. Again, go to cocoras.org and you can sign up, order a rain gauge, and you'll be ready to go. So, and certainly you can contact me if you have any questions about that. So I believe that is the last question. So I want to thank again Bryce and Rodney and Bill for joining tonight and helping out with all the climate questions, especially Bill. This webinar is being recorded, so we will have it posted to our YouTube page within the next day or two, once Bryce gets a chance to throw it on the page. Again, join us next Thursday. We will be hosting our next webinar, and that will be